Hi, hello. So, this time we're going to do the whole tax form where we work out the second moment of area. So, take you through the whole process. We've got a channel, this is called a channel girder here, like a C shape. So, we're going to split it up with two lower sections and a beam at the top. Got all my dimensions in millimeters. So my first stage is to work out where the neutral axis is, and I will do this by using the tax form that I've already seen with breadth, depth, area, centroids, and area times centroids. So fill in the first one. So notice the first and the third one are going to have the same values. I could have ordered them differently. The top one has a nice big section there, so 240 breadth and 42 depth. Same as the previous result. While I'm going through, I could look for the centroids. So the first centroid will simply have a centroid of 30 centimeters, half the 60, and then the top one will have half the 42, so that's 21. Plus the 60, so that gives me 21, plus 60 gives me 81. Next I can work out breadth times depth to find the area, and once I've got the area I can times it by my centroid to find my first area of moment. Do that to the second term and the final term, and then the final stage is to find the neutral axis, that is to add up all the areas, add up all the first moment of areas, and take first area moments and divide them by area. So that's what we're going to do up here, and then we're going to find where the neutral axis is. So it's 72. So always good practice to take your 72 and roughly imagine where that is. So that's going to be 72, would be about a quarter of this 40, so it would be about there for the neutral axis. Seems a sensible position for it to be. Now ideally we would carry on our table, so we would just carry on the previous values. But since we've run out of space on this PowerPoint, we're kind of shift this section up here and then carry on our table, keeping a note of what's first, second and third. So the first thing is to find the h, and the h is the most difficult one. So it's the difference in distance from the neutral axis, so we decided that was there, and the position of the centroids for the other two sections, so they're going to be about there. So a small distance for the 2-1 and quite a large distance for the sort of lower leg sections. So lower leg section 42. Top one only a distance of 9 millimeters away, bottom one 42 again. So next I want to take my area, multiply it by h squared. A lot of students forget to square the h. A lot of students tend to write a times h here and not a h squared. So remember to square your h and then fill it in this column. So that's give us the results for the parallel axis theorem. You're going to get very nice big numbers. Work so that you've got 5 sig fig each time, so write out the answers to 5 sig fig at least. So those are results. So we've got a set of results for the parallel axis theorem part of the equation, and then we're going to use our formula for a rectangle to find second moment of area, taking the breadth and the depth to the power of 3. Breadth times depth to the power of 3, and then all divided by 12. So if we had carried on our table, we would just be looking back along this row and then finding the b and timesing it by the d to the power of 3, divided by 12, and then fill in our answer here. So that's my first value. Obviously use engineering notation, so power to, for example here we got times 10 to the power 6. The reason why you want to use engineering notation and not so for example here not 8.1 times 10 to the 5 is because then it becomes a lot easier for when you want to sum up your data. If you're lucky and if everything turns out to be 10 to the 6 or not far off, then you can add up the numbers, just these numbers, and then put 10 times 10 to the 6 onto your final result. What we're going to get here, another 1 times 10 to the 6, and the same result as previously. So if I wanted to, I could use my calculator, I could ignore these, add these values up, and then do times 10 to the 6 at the end. Might help a little bit, might cut down on a little bit of keying into your calculator. Anyway, sum up these results in this column, sum up the results in this column, and then add them both together. So we need to sum up the column in the right. We're going to use our formula for what is the second moment area for the entire channel girder. So the a times h to the power 2 and the b d to the power 3 divided by 12, their results sum. So those two numbers, we're going to add them up and we get a result of 6.757 times 10 to the 6. This is going to be in units of millimeters to the power 4 because we've decided to work in millimeters everywhere. I've only really got two choices: work in millimeters and get a big positive number like that, or you can work in meters and then end up with a final result of meters to the power 4. So that's it, job done. Another easy work solution.